Hello everybody, it's Weesty, and today I have a bit more of a fun video for you guys. I'm going to run through some theory, then go through an actual test run of how to hack single-player games with leaderboards. As the victim, I decided to go with Burrito Bison Revenge on Kongregate. It's a game I used to play when I was younger, and also you can see on the leaderboards here that this man, Conrear, already has a pretty obviously fake score, so it's not like I'm going to be the first one hacking this pure, untouched game. So, onto the theory. Multiplayer games have a very secure client-server relationship. In a multiplayer game, the server does all the physics, math, and decisions, and sends the proper info back to the client. The client simply tells the server what he wants to do, such as to move forward or to attack. The reason this is so secure is because the server is the one doing all the calculations. A malicious hacker could not simply change some variables to give him more health, make him do more damage, etc. But in a single-player game, the client does absolutely everything. This makes single-player games extremely hackable, as an experienced programmer could reverse engineer how the game works and change some values in memory, for instance. However, this is difficult and time-consuming. There's one more category of games that is even more hackable. In a single-player game with leaderboards, the client still does everything. So how does the server know what your score is in order to place you onto the leaderboards? Well, the main way to do this is for the client to simply send his score to the server after playing. But since the client is the one sending the score, and the client can do whatever he wants, the client can just change the score before sending it. This is exactly what we're going to do in our test run. In order to actually intercept and modify packets, I'm going to use a piece of software called a proxy. The most popular proxy out there is called Burp Suite, but I'm not going to use it for one main reason, and that's because it's not free and open source software. There's like a paid version of it and whatnot, and I'm really a huge fan of the open source movement, so I use a piece of software called the OWASP Zap proxy, and it has worked completely fine for everything I've needed it for. I'm not actually going to go through the process of how to set up the Zap proxy and also how to route Firefox traffic through it, but I will link a video in the description that guided me through it. So here I have my Zap proxy running, and I configured my Firefox web browser to route all of its internet connection through Zap. And I noticed that the moment I loaded the Burrito Bison page, my WebSockets tab opened up. It's not guaranteed, but this most likely means that the game is going to be communicating to the server through WebSockets. So this will be the first place I look. But also, on the history tab, it shows every post and get request that I'm making. So if I do send my scores through a post request, I will see in this tab. Alright, so now I'm just going to go through a quick run through the game and see what happens. Okay, so here I just finished my first run. You can see that I traveled 451 meters. I smashed 19 pigs. So basically I'm going to use these numbers to try to figure out what packet is being sent. Okay, so now I'm back on my WebSockets page after just finishing that. And the first thing I want to do is I only want to look at things that I'm uploading to the server because I don't really care what's coming back to me. So I can apply that filter, and now I'm just going to look at the last couple of packets I send and try to figure if anything looks interesting. Okay, this one right here looks interesting. You can see that I have some message code of stat.submit, which already seems very fishy, and right within this message tab right here, we have this very long base64 string. Now something you'll learn if you're using a lot of base64 with websites is that these three letters right here, E, Y, J, that is always the base64 for the start of a JSON object. So I'm going to go ahead and put this through a base64 decoder and see what the message I'm actually sending to the server is. Okay, so we have here my username, and here's some stats. I don't know what this 74545 number is, but I do recognize this number 19 here, and I'm going to actually check out the page again. And yes, 19 was the number of pigs I smashed. If I actually look down at the leaderboards here, you can see that there's multiple leaderboards. There's one for the number of gummies squashed, one for the best distance, one for the best time, and one for the most doors destroyed. So when I look at my proxy again, you can see that here is the number of gummies I squashed, but then here are, looks like 3 other scores that I've also sent. But for the purpose of this video, I'm only going to change the number of gummies I squashed. Okay, so now I'm going to set up a breakpoint so that the next time I send a score to the server, the program will break, allow me to change what I'm sending, and then continue onwards. So to do that in Zap, I just right-click the packet that I think is suspicious. I go to the break tab, and then I have to choose a pattern for what kind of data within this packet would cause me to stop. Now I'm just going to go ahead and use a regex code that'll stop whenever the word stat.submit is anywhere in there. So the dot just means any character, and the plus means one or more of that character. So I'm looking for any series of characters, and then the phrase stat.submit, and then any series of characters after that. Now I will add this, and I will play the game again and see how it goes. Okay, so now that our breakpoint is set up, let's go ahead and play again. Okay, now you can see in my toolbar, Zap is lighting up because it's ready to tell me that I have a breakpoint. Alright, so this first message is hopefully going to be the number of gummies that I squashed, but I'm going to have the base 64 to code it anyway, so we'll check it out. Okay, this score right here says 36, so yep, that's it. That's the number of gummies we squashed. Alright, so let's go ahead and change our score from 36 to 6,666,666. Go ahead and convert that back. Take our base 64 string. We're going to copy that and just go ahead and, oops. I'm going to go ahead and replace the message right here. And now I will say submit and continue to next breakpoint. There we go. Now we can go ahead and pray, and when I refresh this page, it should update my high score. Now when we go to the high scores page, you can see my score of actually more than I entered, but that's okay with me. And there we are. Now we are in second place on the top of the leaderboards. Alright everyone, thanks so much for watching the video. And just a warning, if you come back to this leaderboards and you see my name is no longer here, don't get all fishy. It's possible that because of this video or just because my score is fishy in the first place, the administrators remove my position from the leaderboard. Secondly, not every single player game is as easy to hack as this one. There's a ton of protections against this hack. So for instance, the data could be encrypted before it's sent, and you would have to reverse engineer the encryption method. Or instead of just sending your score, it could send some kind of other data that would relate back to your score in some way. But for games on Kongregate especially, I've noticed they usually just tend to send a straight up score. Lastly, don't go too wild with the score. I don't need every single game that has a leaderboard to be completely ruined, but also have some fun. Feel free to make fun of bad security.